Moment. This method when attempting any moments questions involving a ladder on the slope. First step is highlight the keywords using a highlighter on the question paper. Will not be scanned if you're using it on your answer booklet. We have a uniform ladder of weight 150, length 4 meters. It rests in equilibrium, is in contact with a rough horizontal ground, resting against a small vertical wall. The ladder is inclined at an angle theta, where tan theta equals 3. Particle weight 750, standing on the ladder at a distance x from A. Find the friction exerted by the ground on the ladder. For answering the question, second step is to draw a very good diagram. Even if you're provided with one, replicate it in your answer booklet because you can get marks from it. Sure your lines are straight so you can clearly see the direction of all the arrows and not get confused. Add all the information you know into your diagram. You really have to remember in which direction your arrows representing forces will go. You can also figure it out. Friction is always perpendicular to the contact surface. Think about a rough ground. Think in what direction will the ladder slip. So friction will try to stop that, acting in the opposite direction. Tip and trick is to draw your force arrows super long so you can see the triangles that we will need later to resolve the distance. Because remember, in moments, distance has to be perpendicular to the force, vice versa. Having a diagram is very important. It will help your brain focus on the keywords while being under exam stress. I'm finishing now putting all my forces on diagram distances. The wall is smooth, so we have no friction acting in any directions. So when you're given an angle theta, my best tip is to work out the value of cos theta and sin theta straight away. You will definitely use it later in your question. The third step is to write down your vertical and horizontal equilibrium. I guarantee you there's not a single ladder on a slope question where you'll not use vertical or horizontal equilibrium. It is always helpful to know which forces are equal to each other. These are only true when you have questions dealing with equilibrium particles, rods, ladders. You should always look for forces that are equal to each other to make up extra equations that will come in handy later on. A really crucial step is to write your friction equation down. R equals R mu. Sometimes mechanics questions are really annoying because they usually have an A1 for this equation, meaning you have to write it down, otherwise you'll not get the mark, even if you get the right answer. Step 4 is to take moments from the ground. In 99% of the cases, you always take moments from the ground because that's the point where you're going to put your pivot on, so you'll not take into consideration any of the forces at A. So I'm drawing a triangle to demonstrate you how we're going to resolve the distance. You can see it's super easy just using Pythagoras. We're working out the perpendicular distance. You can see the triangle super clearly when you have your arrow force super long. If you're struggling to work out if your force is rotating clockwise or anti-clockwise, place your finger at the pivot, this case is the ground, and pretend you're rotating around the pivot with your pen or like finger. Then you can clearly see if the rotation is clockwise or anti-clockwise. In this case, both of my directions are clockwise, so we include the negative sign when you times it by distance. Now we have to resolve our last force, which is reaction exerted by the wall on the ladder. So here, if you're struggling to understand how to draw your triangle, my best tip for you is to always remember you're drawing the opposite and adjacent sides of the triangles. So your force arrow is always the hypotenuse, and you're drawing opposite and adjacent sides. So the distance in this case is already perpendicular to our force. There is no need to resolve it. So now we're rearranging the equation. This is the moment when the values of cos theta and sin theta that were written at the beginning comes in handy and saves you a lot of time. So you can just plug them in straight away and find RW. I recommend keeping exact values until the last step. So the last thing you should do is actually work out the actual values, only if the question requires exact values. So notice how our horizontal equilibrium equation says that friction A equals RW. So this means that once we find RW, we we have found our friction that was asked in the question. For the second part, we're given that coefficient of friction between the ladder and the ground is 1/4. So what's the greatest value that x can take? For this part, we're using our horizontal equilibrium again. We are also using the fact that our friction equals to reaction at A times our coefficient of friction, which is 1/4. According to our vertical equilibrium, reaction at A equals 900 newtons, so we can substitute our A and mu r straight into the equation. Because this equation represents the maximum value friction can take, we say that our expression for Rw has to be smaller or equal to this value. Now we find our x, so we get that x should be smaller or equal to 3.2. Thank you for listening, and I hope you find this video useful. Good luck with your exams. Bye!